So we're just going to quickly do something on, I think it's just the first page here was what I wanted to do. And then we're going to actually take a step away from this workbook just to kind of practice some stuff first. This tends to be something that, whenever I've talked, get really anxious about because it involves some like sets of rules. It's not as concrete in some cases. So I'm hoping we can do a short review session before we keep moving forward here using this information. So what we're going to do, just to kind of start here is, so whenever we've talked about trig, always remember this part of it. You probably remember this part of it, right? Oops, make it a little smaller. The SOHCAHTOA phrase, right? Kind of. It'll be a little bit different, actually. Not quite. So if you remember, so this SOHCAHTOA thing here, where we get those is the S from the sine, the O from the H, the O from the hypotenuse on this top part here. Sine is equal to opposite over hypotenuse. So if you remember, as a quick review, SOHCAHTOA was just an abbreviation. It was a way of shortening, a way to remember these formulas up here at the very, very top, right? So it's the S, the O, and the H. Sine is opposite over divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite divided by hypotenuse. Memorizing these formulas that pretty much anyone who's done a grade 12 math class has had to memorize. It's just one of those things is you memorize SOHCAHTOA. So that's where that comes from. Now, in case you don't remember, like what's this opposite? What's this hypotenuse? What's this adjacent? Those are the three sides of a triangle, right? Whenever we've done triangles, like this one that we see here to our left, right triangle, 90-degree angle, that's what the little box means, right? So whenever we've looked at right triangles, we were able to label a couple of things. First off, the hypotenuse was always opposite of this right angle. The hypotenuse is always your longest side on a right triangle. That's this one here. This is your hypotenuse here, right? You're always going to have an angle you're working with. Let's say, for example, I want to work with angle B right here, this thing. If I wanted to work with angle B, I wanted to try and find, hey, I want to know how many degrees this is. Well, how many degrees is angle B here? All of a sudden, I now have something. I can look through that. If I'm looking the same direction as angle B, which means the last thing left is our adjacent side. So hypotenuse is always opposite that right angle. Opposite is always opposite of the angle you're working with. And then whatever's left is your adjacent, right? Just as a really quick review there. Let me just erase some of that stuff. So if you guys are looking, so we have a triangle here, right? And you're going to notice it's labeled with some things. There's big A's and little A's. So what this triangle here is basically this exact same thing that we've done. So basically, they label stuff. A is this angle right here that I'm continually making thicker and thicker. And then opposite of that is side A. This is side A. It's the little one there. So and you can find that all the way throughout here, right? When you have your big B, your angle B, I can see that, oh, well, here's my side B. That's opposite of that. Opposite of that is side C. That's how they're kind of using this information. Oh. So let's say, for example, if I wanted to find, I'm going to erase everything in this triangle. I'm going to erase everything here. If I wanted to find, let's say, sine of B, because big B, the big B here is an angle, right? If I wanted to find a sine of B. Well, the opposite and adjacent is always depending on what angle I'm using in this case. So right now it's forcing me. You have to use that one ratio. So if I want to try, yeah. So if I want to try and find sine of B here in this case, so first off, so sine is we know our formula, right? So it's opposite over hypotenuse, right? So that's this angle here, right? So what side's opposite here, right? And then what side is the hypotenuse? Because that says H. And so, yeah, they'll see. So sine of B is equal to B divided by C, right? So that's what that would be. And then what about for cosine, Austin? What would that one be? So if I wanted to cos of A. So if I wanted you to try and find cos of A, which is this angle up here. So when you see cosine, you look at CAH, so SOHCAHTOA, what's my formula going to be there? So you're thinking, so this is HA. So it would be, B over. Oh, sorry. So it would be, B over C in this case. So remember, when I look at cosine here, Austin, so this C means cosine, right? Cosine is your adjacent side, which is this one over here on the left, divided by your hypotenuse. So it'd be B. If I wanted to try and find like tangent of, let's say A, if want to try and find tangent of A in this case. I know that's going to be my opposite divided by my adjacent. Nope, no worries. I got your text. I just got your little book up there. So that'd be my opposite divided by my adjacent, which is A divided by B. I will post, you guys are wondering about some stuff. We will spend some of our time practicing this skill, but I'm going to come back to this, okay? But what we really need to understand, what we need to basically understand in the next couple of minutes is we need to be able to label a triangle, and we need to be able to identify which of these three things we use. Do we use so? Do we use plug it into our formula? So what I'm going to get us to do really, really quickly here. So I want us to take a step back, a step away from the workbook. So I have posted a couple things online for you, Lindsay, in case you're interested. Now, for those of you who are here, yeah, you couldn't really hear very well. So. Okay, so I just wanted to quickly kind of practice some of those skills before we go a little bit deeper. So everyone should have, I believe it's this sheet in front of them. Let me load it up on open with Edge. Okay, so everyone should have this one in front of them here. So one thing I want you to remember here is you have a series of steps, right? So your first step is always going to be you want to label your triangle. Your second step is always going to be which of SOHCAHTOA are you going to use? These are just some skills we need. Really, really quick review from what we learned last term. And the third thing we need to know is we need to be able to
Can you get a second? Or just
sorry, I didn't hear you. So no, that's fine. That's why we're doing this. So so we're just going to quickly kind of do some of these here together. So first up, trigonometric ratios, right? So right now we're doing with right triangles. We are trying to find out what is it when it says how many degrees is this angle? This little red thing that I'm drawing in.
Oh.
Yeah, cosine of O. Yeah. But it wants to figure out what's the degrees of this angle. So how we can do that then is, so again, our first step here is you want to label that triangle, right? So I label my triangle, my biggest side, the one that's opposite my right angle is my hypotenuse. This left it, so I'm gonna put O there, which means this last thing here has to be my adjacent. So now I've labeled my triangle. The next step I have to do is I need to figure out which of these three do I use? Doesn't matter in this case because it already tells us specifically which one to use. So it's telling us it wants us to use cosine. So we immediately jump to that third step, which was we want to plug in our formula and then solve. So if you're dealing with cosine, so it's the cosine of, do you remember what this thing's called? Theta. Yeah, theta. That's the fancy Greek thing. That's the angle. How did I get that?
I mean, did you second it? Or second, and then cos?
So it just tells us to do cos right now. It wants us, yeah. So cosine of theta, I'm using cos because it tells me that of theta is equal to, so what's my, if I'm using cos, so that's this one right here that I'm underlining, what's this going to be? What's my formula before we get to the numbers?
A plus B.
So it'd be A divided by H, right? That's what that comma means up there. Yeah. So it's my adjacent divided by my hypotenuse. So remember, that's why we use SOHCAHTOA, right? That's how you memorize all three of those formulas is just through those 9 letters there.
Oh, so we just.
So now what we're doing is we're just plugging in our formula here, right? So cosine of angle O, because that's what it is here. My adjacent I can see is already, it's just 13. Wait, why do I have my actual calculator on here? So now, of course, when you do 12 divided by 13, you get something like this. Now, this triangle itself is not 0.9 degrees, if you remember. The triangle is not 0.9 degrees. So remember, we don't want to figure out what cosine of this angle is. We just want to know what the angle is, if you remember, right? So we need to get rid of this cosine over here. 12 over 13. If you take this whole thing, let me just put it all in brackets. And if you divide that by cosine, it's going to break your calculator, right? So it can't do that. So if you remember, there's a special way in our calculator for it to be able to perform that calculation. That's where we use this second function thing, and we use that little code undecided. We use that inverse function is what it's called. So what I do is I take second function, press that little, yeah, so I press second function, I press the cosine, that puts it there, and then all I'm going to do is I'm just going to put the fraction in there, right? So it's the cosine, it's the inverse of cosine of 12 over 13. Your calculator breaks when you do that. So this is your calculator's fancy way of, oh, they want me to divide it. So what's actually going to happen here is you're going to get cosine of -1 is equal to, sorry, cosine of negative of the inverse of cosine. And you do that of 12 over 13. And if you do that, now all of a sudden you get a proper number, right? So I can now that, oh, it's 22.6 degrees. So angle 0 is 22.6 degrees, if you remember. I hope this is kind of bringing back some memories. We don't have a lot of time to kind of go over and review everything, so we are going to move a little bit fast.
So do we do that second whatever for all?
Yeah. When you're trying to find the angle, yes, you're going to do that second function because you need to get rid of whether this is sine, cosine, or tangent. You need to get rid of that from the angle. No, this is just practice for this. Understand what's happening, but I just wanted to lay it all out here. So again, if I'm going to go do, if I pick like question 2 here, for example, it already tells me tangent, so I'm going to label my triangle. I know this is my hypotenuse because it's opposite my right angle. I'm using angle O again, so I know that this is going to be opposite, which means this is over here is adjacent. And so what I'm going to do is I'm going to take tangent. So what's my formula for tangent, right?
Oh shit.
So think about SOHCAHTOA, right? So not even the numbers, which sides? Opposite and adjacent, right? That's absolutely right. And again, if you're still wondering, where's he getting this opposite and adjacent from? Again, it's all coming from this SOHCAHTOA thing. Tangent right here, right? Tan is equal to opposite over adjacent. That's where I'm getting with that. You don't need to write like this first step. You can just instantly go into like, oh, well, my opposite is going to be 4 and my adjacent is 3. You can instantly go there if that makes sense to you. That's okay. And so then remember, I want to try and find angle O here, right? And right now, I don't know what angle O is because I have that tangent beside it. So what I need to do is I need to, well, I'm not right. I need to separate the tangent, separate the angle. To do that, you use that inverse function. So now instead of taking the tan of 4 over 3, instead of doing 4 over 3 divided by tangent, which breaks your calculator, I use that second function, right? To do that instead. So it's that second function tan of 4 over 3. And if you do that, you're going to get 53 degrees. It will specify in this case. In this case, I don't really care about the decimals. I care about that we can do everything else before that. Yeah. So what I'm gonna do is, like I said, we're not spending a lot of time on this. So what I want you guys to just do here is just practice it for these 4 questions. Pen and paper, that's fine. But I'm gonna give you guys just 5 minutes for this. We don't have a whole lot of time for it. Okay, like I said, we're not done with this. We'll get more time to practice it and identify some stuff. But so first off, what were we using here? We were using something to find something. Fill in those blanks. What's the somethings? Or what do we know about these triangles? We know it's a right triangle, and what else do we know about them?
The sides.
Yeah, we know the sides. So we're using 2 sides to find an angle. That's what we did, right? We use sides to find angles. Now, did you guys remember an angle and a side to figure out a missing side? So let's say, for example, imagine there's no numbers here. Like imagine this triangle here didn't, I don't know. Let's say, for example, I told you this is 10 and this angle over here is, I don't know, 30 degrees. And I wanted to use 2 things. So now we're going to quickly review that scale and then we're going to start moving forward. Okay. So I have another one just to quickly hand up here that we'll go over. It's the same type of scale, but these are the 2 steps. Remember, these are for a little bit. That's the wrong thing. I think I printed off the wrong things, guys. Let's see. Let's go into it. Well, okay, I printed off the wrong things. I uploaded the wrong things, so we'll kind of just power straight. So I'm going to get us to go back to our workbooks now. So first off, it seemed like everyone started to get, look, from what I could see, it seemed like it was starting to click a little bit for everyone. If you're not like like I think I get it, that's okay right now. That's what today is. Today is we're going to take a deep dive into it tomorrow. So these first couple questions here, First off, you see an example here. Try and resist the temptation to look on the bottom half of the page. The full solution's there, but I just wanted to take a couple things here because this is now introducing it into it, which is the second step, is identifying which formula we use. I remember that being an area of difficulty sometimes last class. So for example here, what I have in this case here, I'm gonna do question B first. So first off, right now, what am I trying to find in question B? And this is on page 257. What am I trying to find in question B?
Divided by.
Yeah, I want it to be x is equal to this many degrees. That's what I want, right? And I have two using sides to figure out triangles. I know I need to use, or figure out an angle. I know I need to use trigonometry. So my first step, if you remember, is I'm going to label my sides, right? So I know this over here is my hypotenuse. This is my opposite. This is my adjacent. What are the two sides that have something there?
The opposite and the, adjacent and the.
So the two things that, the two sides that have, sorry? So we're not using tangent because there's nothing with O. O doesn't actually have anything here. So it's a blank side. So what I need to actually do is sorry? I'm on page 257 on question B. So I have my adjacent and I have my hypotenuse. Which of that trigonometry has A and H? Yeah, cosine, right? So this was something that we struggled with a little bit last term, was just understanding which one of these to use. You guys all just proved you could all do it. The tricky part here was, well, which one do I use? So if you remember, I have a measure associated with them. If I have A and I have H, I use cosine. And so what's my so cosine here is equal to, I'm just going to save some space. Sorry, it's not cosine, it's cosine of my angle x is equal to adjacent. What's my adjacent? Yeah, 15.2 divided by my hypotenuse, which is 17.8. Okay, this is exactly what we just did. Now all I need to do is I just need to turn this cosine, right? So I need to get rid. Yes, so you do that second inverse because I'm splitting these two things. I need to get rid of that cosine, right? So technically what's happening is I'm dividing by cosine. Your calculator breaks when you do that. So that's why we're going to do that second inverse. So what this is going to look like then, so what your calculator, it's the inverse of cosine. That's what that -1 means. And it's just this fraction. And so if you guys put that in, what do you get as an angle? So what do we get as our angle when we punch that in? Sorry? So when you do that, take the, so you do cos -1 of 15.2 divided by 7.8. Oh, 31. Sorry, my ears aren't. 31 degrees. So again, that's exactly what we just did. The thing that made this a slightly more harder problem was on this sheet, it said use cosine, use tan, use tangent, use cosine, use sine, use sine.
I know.
Yeah, and that's right. And we do that by just identifying the sides as, hey, these are the sides I know things about. I know these sides are this long and this long. Those are the ones I use. Okay. So now I'm gonna go up. I'm gonna go to question A. So first off, on this last triangle, I used two sides. Is for question A, I'm using a side and an angle to find a missing side. So first off, I start my thing the same way, right? I'm gonna label everything. This is my hypotenuse.
So if the numbers are, so if we do sine 28 and then x over -4.
For which question is this?
One.
Are you looking down?
Oh,
Oh no, yeah, no. So first off, I'm labeling my sides here, right? Now, here's the thing. What's my opposite side? Look at the angle you're given. That's your reference point here, right? So this 204.9, that's your opposite side because it's opposite of the angle you know. And then this last side's my adjacent. Okay. So what are the two sides here that have something with them? There's opposite, of course. And then what's the other side?
There's no side.
Well, there's no other side, but this adjacent here, it does have something there. It has what I'm trying to find. So that's what I'm going to use, even if we don't know what to find. So first off, I'm just going to kind of cross this off just so we don't interfere with it. What my ultimate goal here is, it's going to say, hey, x is equal to this many centimeters. That's the ultimate goal I'm trying to get to here. Let me just zoom out a little bit. Okay. So which asymptote do I use here?
Yeah.
Tangent, yeah, because I have O and A. So that means it has to be tangent. Because TOA right there. So tangent of, now what do I put in these brackets?
67.
because I know the angle this time. So tangent of 67 degrees is equal to my opposite, which is 204.9 divided by my adjacent, which this is the other thing that most people struggle with was we have to manipulate this equation, if you remember, right? Right now, x is on the bottom of fraction. My end goal, as we've already talked about, is to get x by itself on a side. So what I need to do is I'm going to need to get x away from that fraction. So I'm going to times both sides by x with is I'm going to be left with tangent of 67 degrees times x. And then on this right side, I'm just going to get 204.9. I know that's a tight fit. I apologize. It's kind of narrow. So I've done my first step here. So I need to get x by itself, right? So that's why I'm doing this stuff. I need it to tell me that, hey, x is equal to this length. And to do that, it needs to get away from that fraction, and then it needs. Yep.
I'm not sure if I'm doing this right. Can you do number one?
We'll get there. We'll get there.
So if we're not dividing, so we can ever times by the sign.
Yes. So we're about to. Yeah. Sometimes you do. Yeah. So what I've done right now is I've got an x to it is this tangent of 67 degrees, right? So to get rid of that, I need to do the opposite of what's happening. So the opposite of being times by tangent is dividing by tangent. Now, here's the other thing most people struggle with. Matthew, you're dividing by tangent. Aren't you going to use the second function symbol? No, you're not. You only use that second function symbol when you're with the angle. I'm not splitting them up in this case. I'm moving the whole thing all at once. So now I'm going to divide by this tangent thing. That cancels out. And all of a sudden, I'm going to be left with x is equal to 204.9 divided by tangent of 67 degrees. And so you can just punch that in your calculator exactly as you see it. 204.9 divided by tangent of 67. You can use that fraction button if you want to. So if you do this, you should now end up with, it'll give you a side. I'm just going to put 87 centimeters just to, because I don't care about the decimal right now. You could look at the decimals if you want. I'm just going to personally put 87. So in this case, x is equal to 87 centimeters is your answer for question A. The thing that I find most people struggle with, though, is this thing I'm doing in green, is these two things right here. It's a two-step equation, a little bit. Just take it one step at a time, right? Times both sides by x, because that cancels out x from the fraction, brings it to the other side. Then get x by itself, which means getting rid of this tangent of 67 by the same thing. And then these two things cancel out. And now I'm left with x is equal to something I put in my calculator. Like I said, if you're a little confused about this, that's okay. I get it. We're kind of reviewing like a week worth of stuff we did all in one go. So if you're unsure about this, I will post some videos able to review it. You could look back at some of your notes from like last block, for example, but you need to come here tomorrow being able to do this stuff. It's just something that needs to happen. This is usually why students find this to be one of the most difficult units, is just because if they didn't do too well with trade in the last class, they now have to catch up on that work and learn new stuff. So you want to come in here tomorrow being able to do this. That's the goal. That might require you to do some work at home. Okay. So practice those exact skills. You're just practicing exactly what we did up here in these examples. Just on, there's 2 pages of questions here. You want to be able to do this because you're going to need to be able to do this kind of fluidly as we go on. So we'll do question 1 together here. And by that, I mean, I'm going to also, what's my first step here for question 1?
Label the triangle.
Label the triangle, absolutely. So you tell me what to label. Yeah.
The opposite.
Yeah, x is the opposite because it's opposite angle. Yep.
The bottom one is J.
Perfect. Yeah, absolutely. And then Aiden, so what's my next step now, Aiden, to solve this?
Take the sine cos pairs.
Pick sine, cosine. Yeah. So how do I know which one I'm going to pick?
OA.
OA, yeah. Or sorry, O and
Is H.
O and H.
Oh, because it has the number, sorry.
Yeah. So sine,
28
yeah. So sine of 28 degrees, good. That's a really common thing.
with 9.4 over X.
So
X over 9.
So I can see it has like O first, right? So you're gonna put your X first here, your over. Does that make sense? Like why I'm putting the X there first?
Yes.
Okay, cool. And then Kim, what's my next step here?
Well, I put vortex sign.
Oh, okay. So that's what we're gonna end up with. So what we're doing here. So remember, our ultimate. No, but you're right. So let me. I'm just gonna kind of get us there. So first off, my goal right now is X is by itself. X. Here's the answer. X is equal to blah.
So you want to get something
right?
times 9.4.
Yeah, times both sides by 9.4, yeah. And then I get exactly what you got there, Kim. So you got sine of 28 times 9.4. That's it. So that's what you got. So you're absolutely right. And then all of a sudden, I'm just left with x. Because remember, these two things cancel each other out. They don't exist anymore. So now all I do is I just plug this in my calculator, it gives me an answer, spits out what I need. So I take sine of 28 times 9.4 equals 4.41. Or you can even just put 0.4.
I just use one this one.
Oh, yeah. Yeah, frankly, as long as I know, like you could have it, as long as it's not like a whole number, you're good. But okay, so I'm gonna give you, I don't even know, 1, 2, 3, 4, 5, 6, 7. I will give you till 2 o'clock to work through these. Then you'll have your break when you cut, just to work on some of this stuff, because we're going to be starting our introduction of our new skill after that. Okay. So again, please ask for help if you need it. You're going to have to do a bunch of different things here. So look up at this question, see what we did, figure out. Okay, so you don't need to write down what I'm about to write down. So you don't need to write down what I'm about to write down, but basically, so first off, we've been able to do a couple things with right triangles. So with right triangles, what we've been able to do is we've been able to use, sorry, not that. We've been able to use two sides to figure out an angle. We've been able to use one side and one angle to figure out a side, and we've been able to use two sides to figure out three sides. These are some of the skills that we've learned with right triangles. Right now, I'm on page that we've learned through this course and through last course as well. It's three skills we've been able to do with triangles. Now, all of these have a couple things in common. I mean, sides and angles, but also the fact that it's a right triangle. You probably can see where I'm going with this. What if I triangle doesn't have a right angle in it? These things now no longer work when you take away that right angle. These rules exist only for those right angles. So if you take that away, things are different now. Now we need to explore some different concepts in order to do that. Yes. So we're kind of introducing a little bit thing here. So when I say a non-right triangle, it's technically called an oblique and have a right angle. Okay. You don't need to remember this word. That's okay. If you just want to be like it doesn't have a right angle. That's okay. We get what you're saying when you say that, right? That makes sense. Solve all this stuff. Now we're taking away the right angle. Now we're starting with a blank canvas. None of that stuff applies to this, okay? That's a really important thing. If you're given a non-right triangle, an oblique triangle, and you instantly start using Pythagoras or SOHCAHTOA, it's not going to work. Tell us about it, okay? So we know a lot of stuff about triangles. We know nothing about non-right angle triangles. We know nothing about them. So when we have the sine law here, I'll explain what that is in a second. So the sine law is when we can figure out, so if we can figure out a side length or an angle that we don't know. So first off, you're going to see that we have, this is the sine law right here. And you don't need to memorize it. This is something that's going to be given to you on your departmental final exam. Okay? Which was? Oh, the ratio of angle? Yeah. Okay, that's good because that ratio part's actually pretty important. So, well, that was the machine. I didn't do that. I wasn't like, you know what? I'm going to ruin Kim's day when I was printing this. So I know you guys don't have this in yours. I guess back to in a second. We'll learn more about that probably tomorrow. But so this thing I've highlighted, and I want you to box that, star it, something. That's the sine ratio, okay? You'll get that on a formula sheet. You don't need to memorize it. You just need to understand what it means, which is what we're about to go into. So basically, here's what it's saying. So if I take sine of A, this is an angle. If I divide it by side A, let's say, for example, I don't know, maybe this is, actually, I won't even give numbers to it. If I take angle A, I divide it by side A, it's going to be if you punch that in a calculator, you're going to get the exact same thing as if you did it with angle. I'd almost recommend it. So this red thing here, that's going to have the exact same ratio as this blue one. Let me just erase that. I didn't do that very well. It's going to have the same ratio as this blue one, which is going to have the same ratio as this green one here. I know that's a little messy. But so that's technically what this is saying. We'll explore this as we go a little bit further. But when you set this stuff up in this way, you take the angle, you divide it by the length of the side, it's going to be you're going to get the exact B. And then if you do it for the next side C, it's going to be the exact same answer. And so when we know that information, when I know that, hey, this red thing is going to be it's going to be the same number as this blue thing here, all of a sudden I can use that information to find missing stuff. This is a ratio stuff. Let's throw way back to there. So I'm just going to zoom out a little bit here. So we'll use this. We're going to use this here. Red. So there's two situations when we can use this. We can use this when we have two sides and an angle opposite one of them. You don't need to memorize this. This is okay. When you have two sides and an angle opposite of one of them, or you can use it when you have two sides and there's a side opposite one of them. So when the angle's opposite or the side is opposite one of them, okay? And so I'm just going to erase these colors in this shape here to give you an understanding of what that kind of looks like. So let's say, for example, I don't know, this one is. Okay, so if you look up at this little triangle I've done up here, so what I've done is I've labeled two sides and I've labeled a missing angle. I know I can use the sine ratio for this because I can see that one of those sides has an angle opposite of it. So that's why I drew those little lines earlier, is because it makes it a heck of a lot easier to be able to see that there's some matching stuff that's happening there. And you're probably gonna want, this is the sine ratio. This is where we use it. Now I'm going to show you, now let's actually start using it a little bit. Let's use this a little bit. So we're going to use this one here. Again, I'm going to ask you, try and avert your eyes. There's the answers right below it. Please try and avert your eyes. So first off, when I look at this triangle, first stuff we've learned, I don't get to use it. So this is the next page. It is not a right angle triangle. I cannot use Pythagoras. I cannot use SOHCAHTOA. That is out of the window. So I then know I need to use the sine law. So what I need to try and do is I'm trying to find side A. So what I recommend you do is check and see what sides have stuff with them. So I'm going to draw my little arrow here. Oh, let me make that a little bigger. I'm just going to draw my stuff here, connect my two sides, my angles.
Oh, we have to find A or C.
Well, we'll get there. We'll get there. That's why we're going through it. Yeah, so that's why I like doing these little pictures here. It makes it a little bit easier. So have an angle that's opposite of them, or angles that have a side opposite of them. We're looking for stuff that's opposite of each other. And so if I do that here, all of a sudden I can see that I have two things here that are the exact same. I have two things that have an angle and a side that are opposite of each other. So that's what I'm going to use. And so what I need to do is I need to use these three things, the 72, the 62 is I'm going to go to my formula up here, and I'm going to take a look at it. So first off, I have A and B here, right? So I figured out that A and B have something opposite of them. So I'm going to go here. I'm just going to use angle A. I'm going to use A and B. So I'm going to just quickly write that in. You'll see what I mean. So I'm just going to write sine of A divided by A. I'm just taking that blank formula is equal to sine of B divided by B. The reason I'm using those two is because it's two blank things. I don't know any of that stuff.
We're just doing opposites.
Yeah, we're just doing opposites, just like you can see there. Yeah. So I'll explain why we do opposites here right now. So first off, I'm just going to plug the stuff in that I know. I know that. And I know, and then I just have A. I don't know what it actually is yet, but I know that's what I'm trying to find. And that's equal to sine of B, which is 52 degrees. So you're going to need your calculator for what we're about to do, just to kind of show you something. Is equal to 16.8. Okay, so here's what the sine law dictates. You don't need to circle one about the circle. So the sine law says that if I take this and punch this in a calculator, and I want you to do that right now, take the sine of 52 divided by 16.8.
Oh shit, I did it wrong. I times it for some reason.
So take the sine of 52 divided by 16.8.
I did.
So right now, if you do that, you get something. Again, don't write this down. I'm just writing it down to show a pointer. So what the sine law says is that whatever we got here, which is this 0.0469, if I take sine of 72, and if I were to measure side A, this green line here, if I were to measure this, sine of 72 divided by however same answer for each of these. That's what the sine law is saying here, okay? This is a ratio, is equal to this ratio.
So sine 72 divided by 0.
Not quite. I just know that's what that's going to equal. So I know what this is going to equal, but that doesn't tell me what A is. So what we're actually trying to do here is solve A, but that's just all we need to do is, I just need to try and get it so that I can get A as an answer, right? A is going to be equal to something. So A is going to be equal to something. Okay, so don't write down what I'm about to do. What we're used to doing, and you are more than welcome to keep doing it this way, is I need to get A by itself, right? And to do that, I need to times both sides by A. Again, don't write this down. I need to time both sides by A. Then I would by sine of 52. Then I would need to divide or times both sides by 16.8. That'd be a 3-step equation, right? That's technically how the way we've been practicing how to do it, doing it one step at a time. There's some cheat codes we can do there. You are welcome to keep doing it. That works for you. Do it. But so I'll get there. I'll get there. So another way you can do, and you do not have to do it this way, but I'll show you a way. So first off, my goal is I need to get A by itself, right? In order to do that, I need to get A from the bonus fraction. So let's just kind of all do it in one quick step here. So it's by A. If I times both sides by A, what's going to happen? It would be on the right side, right? So I'm drawing this little arrow here. This is indicating that you want A is going to move to this side of the equal sign. A is going to move over here. And I'm going to do it all in just this top line. Now, the next one, then times both sides by 16.8. So I'm writing times because I'm timesing them by this, right? And then what I would also do is I would also need to divide by the sine of 52 degrees. So I'm kind of showing all my work just by doing it all right in there. But basically, instead of having to do it step at a time, which you can't, but what you're able to do is you're able to like cross multiply, cross divide here in order to do it. And all these lines show is that, hey, you see the 16.8? I'm going to move it to this side and it's going to times into this. And what this is eventually going to look like is, okay.
I was wondering like how I got that.
Yeah, so I'll show you how we've traditionally done it right after this. A is going to be equal to, it's going to be 16.8. Oh yeah, sorry, sine of 72, nothing's happened with that. So that still stays. So sine of 72 degrees still stays here. And I can see it's being times by this 16.8. And that whole thing's being divided by, because I wrote up there, of the sine of 52. Technically, this is what you're going to end up with. And if you're looking at this stuff and you're like, what the heck did he do? Oh, so you got 20. Yeah, I'll just go to 22.7. That'll work.
No, 20. Wait.
20.7. Thank you. Oop. So what you got here was you got. Yeah. We can just round it to 1. Yeah. Like once we get to this point, you know, what if you're able to do all this work, like at this.
Decimal 27.
Oh, in this case, yeah. So again, if you're looking at this and you're like, what the heck did he do? I'm just going to quickly write it out over here what happened. So I'm just going to write my blank equation really quickly. I'll make it black so it's actually a little easier to see. You do not need to write this stuff to the right if you don't want to, as long as it makes sense what's happened here. If what I just did earlier does not make sense, I'd recommend writing it down because the way I'm doing now is how we've traditionally done things. But this is now a 3-step equation. So what I'm doing on this right side is traditional way is I need to get A by itself. I need to try and get A by itself. So I'm timesing both sides by A. That crosses out. I'm gonna be left with sine of 72 is equal to sine of 52. Yeah, divide or times A all over 16.8. Now, cool. I have A on top. Now I need to get A by itself. So what I would do then is I would times both sides by 16.8. And all of a sudden I'll be left with sine of 72 times 16.8.
The little letters go at the bottom.
I'll get there in a second. I don't want to jump all over the place. Same thing I got pressed up. And then I need to divide by sine of 52. So both of these show the exact same thing happening. Black. So all of these things show the exact same thing that's happened here, but this is complicated algebra now, right? This is a 3-step equation. It's difficult. You're going to have to look at this and immediately figure it out, like what you've done on this left side here. Great, all the power to you. If you want to do it one step at a time on the right side, which is how we've done stuff all year, nothing wrong with that. It works. It's just a little bit longer, okay? But you need to be able to solve equations eventually. You need to isolate the thing you don't know is really what needs to happen here. And yeah, either way, you're going to end up with the exact same answer. So I'm just going to leave that there for 30 seconds in case you want to write that down. I know it's very small and messy. I apologize. It's a lot of information. I'm going to quickly fill my water and then we'll keep going. looks like everyone has that down. Okay. So I want to just take a quick step back. I don't want all this algebra to detach from what we're really trying to focus on here. These two sides are the exact same thing, okay? So again, I now know that A is 20.3. Theoretically, I should be able to take sine of 72, divide that by 20.3. Does anyone recognize that number? 0.046. That was exactly what you got when you took sine of 52 divided by 16.8. They're the exact same thing. So I want to take a step away from the algebra. We know we solved it, but the main point I'm trying to make here is that these two things are equal, okay? It's a ratio. Again, sine A, so sine A over A is it's equal to B over B equal to C over C. That's what the sine ratio is showing you, okay? That's what that sine law is telling you. 3, because it doesn't matter which one. You could use A and C, you could use B and C, you could use A and B. It doesn't matter. You just need to use 2 of those 3. And so you're looking at what you're trying to do is you're trying to do these little opposite lines here until you figure out that you have, okay, I have 2 things that are. So let's put that into practice here. Let's work on question C here. So work on this one together. So first off, I'm gonna connect my lines, right? So does this angle Y, does that have something opposite of it?
Yeah.
Yeah. No, this is an unknown side. We do not know what this is. So I'm going to leave it blank. And then angle Z, I can see it does have something opposite to it. It has what I'm trying to find, right? That is something. Even though I don't know what this side is, I know I'm trying to find it, and that makes it count. So here's my question. Well, where the heck C? Which one do you use? Does it really matter? All I need to know is that, again, if I take sine of an angle, let's what's one of the angles I picked?
I got sine 132.
Okay, so sine of 132. Cool. And then what's the side that it?
Over 17
Yeah.
equals sine
Equals sine of 15 over Z, which is something we don't know. Yeah. Or it could be Z, X, C, something, right? It could be a big question mark. Yeah.
That can translate plus, I think you have to divide.
So in this case, I'll just kind of label out the steps here. You would times by Z or by C, then you would times by 17.9 or 1794.3, and then you would divide by sine of 132.
Sine 15.
So
1794.3.
Yeah,
And then times 132.
and then it's divided by 132 because 132 is because so what this one would look like, you would end up getting, so Z is going to be equal to sine of 15 times 1794.3. Oh God, sorry, let me fraction that. 17 backspace. So what you should ultimately get to, and then 132. So this is what should ultimately be. That's so it should be Z is equal to this technically is how that will eventually get up to. 624, yeah. So my experience is most people are pretty okay with setting it. They're able to do this part, which is half the battle. It's the algebra that tends to be the confusing part.
So like 635 meters. That's what I think.
Yeah, it'd be 624.9 meters. Yeah.
So basically, like just.
Yeah. So right now, like I see, so Z is what I'm trying to find. I need to get Z by itself.
These other side,
Yeah. And so like,
Yeah.
and everything else you can put together. The main part is well, am I timesing or am I dividing, right? If it's on the bottom, you're timesing. Yeah, if it's on the bottom, you have to times to get it to the other side. If it's on the bottom, you need to, yeah. But I don't want that to take away from what that sine ratio is, because there's going to be times where you don't need to use the algebra. You just need to understand that these two things are equal to one another, okay? So what I'm going to give you, I'm going to give you guys some time to finish up the rest of this stuff. Same thing. If you're unsure what the heck is happening, please that's not going to help you in this case, okay? It is a difficult unit, okay? I'll just be upfront with that. This is a difficult unit. It's not one of those things you can be like, I'll just figure it out tomorrow. You won't. So let's handle it now, okay? So I'm going to give you a little bit of time here just to power through the rest of this stuff, okay? No matter what you do, it's going to be one of those. Actually, no, it can either be a 1 or 3 step. Never mind. So for the rest of the class, you just get time to kind of work on some of this build your skill stuff. We're going to be spending more time on just the sine ratio tomorrow, just the sine ratio. And then there's another part of this unit as well that we'll focus on.